Okay, so I hope this part makes sense, guys, here. Now, the next last ones are the acids. So before I go to the acids, guys, I want to talk about polyatomic ions. Okay. Now, guys, this is one list that you're actually supposed to memorize. So let me show you the list for. Let me see where it is. Where did I save it? So polyatomic ions. Here's the list. So, guys, these are some polyatomic ions that you're responsible to know. So, first of all, what does this mean? Polyatomic ion. The term ion, I know all of you know that ions means charge. You see, all of them have some kind of charge, positive or negative, doesn't matter. Now, polyatomic meaning what? They're made up of more than one atom. Atom, poly, more than one atom. You see, this thing is made up of nitrogen and oxygen, two different atoms. So this is ion, which is polyatomic, so polyatomic ion. And you see they have names for them, like NO3 minus is nitrate, NO2 minus is nitrate, NH4 plus is ammonium. They all have names to them. Now, for an online class like this, you can keep this list handy and use that on the exam. But I just want you guys to know that in a normal semester, a face-to-face class, you're responsible for memorizing this, and you're not given this list on the exam. And then I usually give out some tips in the class as well to memorize this as well. So now, guys, one thing to notice here is something to look at. Let's look at this example here, guys. You see chlorine, 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 chlorine with 1 oxygen, 2 oxygen, 3 oxygen, 4 oxygens. Let's pick this one. What is this one called? This guy is called chlorite. So when this guy is being called chlorite, get the thinner pen. So you see we have chlorite, and chlorite formula is ClO2 minus 2 oxygens. Look at chlorate. Chlorate has 1 more oxygen than chloride. How I usually remember this? You see chlorate, 8, actually 8 1 more oxygen than chloride. So chlorate 8 1 more oxygen. So chlorate or any of the 8 that we're ever going to see will have 1 more oxygen than 8. So let's confirm that from some other examples. So look at phosphate. Phosphate is 3 oxygens. Phosphate should be 1 more than 3, and it is actually 4. Okay, so phosphate or any 8 is going to have 1 more oxygen than 8. You can see that here as well. Sulfite is 3 oxygens, sulfate is 4 oxygens. Nitrite is 2 oxygens, nitrate is 3 oxygens. That's one thing that you can keep in mind. The other one that I usually help students to remember this is, you guys know what is high blood pressure and low blood pressure? Like high blood pressure is called hypertension and low blood pressure is called hypotension. So you see something less than chloride. By that I mean, see chloride has 2 oxygens. This guy has 1. So it has 1 less than chloride. So it's hypochlorite. It's less than chloride. So low blood pressure, chloride here, okay? Like hypotension. Then look at chlorate. Chlorate has 3 oxygens. And this guy has 4. So it's more than chlorate. So it's hyperchlorate. But for some reason, we do not keep hyper in the front. We just keep per. So remove the high. So perchlorate. Again, these are some tips that you can use to memorize these formulas. Okay. Now, polyatomic ions, guys, they're negatively charged or positively charged. So when you combine them, they're going to behave like ionic compounds. So let's take an example. Okay. So let's say I have sodium phosphate. So sodium. So again, when you have the name, just like this one, when you have the name, you're going to go to the formula. You must get the charges. Sodium is Na plus 1. And phosphate, if you're going to look at that chart, it's PO4 minus 3. So if you got Na plus 1 and PO4 minus 3, and you do the crisscross here, guys, Na gets what number? Na gets that 3. Ignore the charge, okay? So don't put negative 3. because you cannot have -3 sodiums. And then PO4, guys, is going to get what number? It's going to get number 1. So you do not put any number here. So Na3PO4 is the answer. Okay. Now, let's take one more example, guys. Calcium phosphate. Calcium phosphate. We're going to do the same thing. Calcium is +2. Write the symbol and the charge. Phosphate is PO4 -3. Now let's do the crisscross, guys. By that I mean take the 2 and put it down here, and take this 3 and put it down here. So calcium gets the 3, that's simple. And PO4 gets a 2. But you see, guys, this looks weird. It looks like 42. So you don't want that. Whenever you have polyatomic ion more than 1, you must put a parentheses. So calcium 3 phosphate will look like Ca3, and then PO4 is 2. There are going to be 2 phosphates, okay? All right. Again, guys, the numbers in the bottom tell you how many calciums you have. Number in the bottom tells you how many phosphate you have, not the charge of calcium and phosphate. We can figure out the charge by reversing it, but that's a different thing. Okay. Now, let's talk about acids a little more. So talking about the acids, we learned that acids are 2 types. If you remember the examples of acid, we learned 2 examples. One was HCl and one was H2SO4. These are 2 different species of acids. By that I mean, we're going to learn that we're going to divide our acids into 2 types. One is a binary acid. They're made up of 2 things, H and Cl. H and sulfur, something like that, okay? And then you have OxyAcids. They're made up of polyatomic ions. They have more than 2 atoms. Like binary have 2 atoms, H and Cl, H and S, H and phosphorus. See, 2 atoms? I'm not counting total how many, I'm just saying how many types of atoms. 2 types of atoms, H and P. And oxyacids, guys, example is H2SO4. Do you notice, first of all, you notice they have oxygen on them, which these guys don't. These have oxygen, and they're made up of polyatomic ions. And polyatomic ions, you saw the table earlier. So SO4 is in this list. SO4, you see that? Sulfate. So it is a polyatomic ion. So when you see a polyatomic ion, and how do you recognize polyatomic ion when you quickly look at the molecules? Can you guys see here? H2S and H2SO4, why are they different? Because here you see you have 3 atoms, H, S, and O. That indicates there must be a polyatomic ion hiding somewhere. When you only have 2 atoms, you cannot have polyatomic ion in the compound because polyatomic ion itself is always 2 atoms. It's polyatomic, okay? So if you make a compound out of polyatomic ion, it has to be more than 2 atoms. Okay. So now, guys, oxyacids and binary acids, they're different in their names because they look different. So this is called sulfuric acid. Again, in the acids, you add ic acid at the end. And this guy is called hydrosulfuric acid. You can see how small difference is in the name, but their formulas do look different. So this guy also has ic acid in the back. So sulfuric acid, that's common. But this guy has hydro in the front. And hydro indicates it's a binary acid, right? So guys, because see on the exam, if I ask you what is the form of hydrosulfuric acid, I'm not going to be telling you whether it's binary or oxy. It's your job from the name hydrosulfuric acid to know that hydro indicates it's a binary acid. So you're not going to look for polyatomic ion. On the other hand, if I say sulfuric acid, you're going to be thinking about polyatomic ion because it does not have the prefix hydro in the front. So no hydro in the front meaning it's an oxyacid, so it must have a polyatomic ion. When you see hydro in the front, it's a binary acid, so no polyatomic ion. Okay, so now guys, when it comes to polyatomic ions or oxyacids, we learned H2SO4 was one example, and we call this guy sulfuric acid. But then there's also one more acid with the sulfur, where the this is also, you can see it's an oxyacid. There's a polyatomic ion, but this polyatomic ion is a little different. SO3 is which polyatomic ion? Let's go here. SO3. Guys, SO3 is sulfite and SO4 is sulfate. So if I go back here and I look here, this guy is SO4, so this guy is made up of sulfate with an 8. SO3 is made up of sulfite, made up of 8. So there's got to be a difference in name. I cannot call this guy also sulfuric acid. This guy is called sulfurous acid. So again, you should see that we have changed our suffix. Instead of using ic acid, we are using us acid. So guys, there are going to be no more rules from here, but we need to, again, understand this carefully. So for acids, we have two types of acids. We have binary acid and oxyacids. Binary acids do not have polyatomic ions, no polyatomic ion. Oxyacids have polyatomic ion inside them. Binary acids use hydro prefix and ic acid as the suffix. Oxyacids do not use hydro in the front, but they use ic acid or us acid depending on which polyatomic ion they got. If they got 8 or if they got 8. Okay, so I hope that makes sense, guys. We're going to do one more example for acids, and hopefully that will clear the nomenclature for acids. So what I'm going to do is I'm going to write down 3 names. Your job will be to find out the formula. So the first one is hydrophosphoric acid. Then we have phosphoric acid. Then we have phosphorus acid. So now, guys, if I give you these 3 names, you should be able to tell me what are the 3 different formulas are going to be. And let's see how we're going to get to the answer. So hydrophosphoric acid, phosphoric, and phosphorus acid. First of all, when you look at them, what do you notice? I notice a hydro here, and I don't see a hydro here. So what does that mean? This guy is binary acid. This guy is oxyacid. This guy is also oxyacid. So if both of these in the back are oxyacids, how are they different? This guy is ic acid, and this guy is us acid. So first of all, let's go back and look at binary oxy-oxy. Binary meaning no polyatomic ion, right? And then phosphoric and phosphorus acid, which are oxyacids, mean what? They have polyatomic ion. Okay, so guys, again, pay attention when I'm saying polyatomic ion or no polyatomic ion. Polyatomic ion. Here, when I say no polyatomic ion, I don't mean there's no ion. There is ion, but it's not polyatomic. So in binary acid, you do not have polyatomic ion. So which negative ion do we have? We have phosphorus. You see, this is made up of phosphoric. This is phosphoric acid. This is also phosphoric acid. This is also phosphoric acid. So the main component is phosphorus. So we do have phosphorus here, but it's not a polyatomic ion. So it does not have oxygen with it, but it's still an ion. So you still need to put the charge. So phosphorus is going to be what charge? It's going to be negative. But what negative? So you go back here, periodic table, phosphorus. You go back here, phosphorus, this guy. Phosphorus is -3. So you go here and say this is P minus 3. Okay, now phosphoric acid, phosphorus acid, both are oxyacids, both have polyatomic ions. So which polyatomic ions do they have? Since this is ic acid, it must be phosphate. And since this is phosphorus acid, this must be phosphite. So phosphate becomes ic, ite becomes us. And you should know that in the reverse order as well. So if you see what is phosphate, phosphate is PO4 minus 3, phosphite is PO3 minus 3. How do I know this? You know that from this table. Phosphate is PO4 minus 3, phosphite is PO3 minus 3. So we got the negative part. We got the negative part. P minus 3, PO4 minus 3, PO3 minus 3. But is that the acid? No. It's not complete yet, guys. Remember, the acids always have hydrogen on them. So you need to put hydrogens on these guys. Acids have hydrogen, guys. Acids, they have H on them. So guys, if I add H to this, and by that I mean, guys, when you're going to add H, you must add H plus. You must add H plus. How many H plus we're going to need, guys? We're going to do that from the crisscross, right? So basically what I'm doing here is I have H plus. I'm just rewriting that to summarize. We have H plus and P minus 3. We have H plus and PO4 minus 3. And we have H plus and PO3 minus 3. So this is what we have, guys. Now, in order to get to the formula, the compound formula, what do you do, guys? You do the crisscross. So H gets 3 and P gets 1. So H3P is the final answer for hydrophosphoric acid. Then again, do the crisscross. And guys, if you're wondering where we got the H plus 1 from, H is in group 1 right here. So it's also always plus 1. Guys, hydrogen can be plus 1 or minus 1. It is that dicey atom. It can act as positive one or negative one when needed, but generally speaking, it is considered a non-metal. So usually negative, but then when it comes to charge, don't follow the rule of hydrogen being non-metal, so it should be negative. That's not the case. Hydrogen is much more easily found as a plus 1 charge. It depends on hydrogen is with somebody negative or positive. That will decide if hydrogen has to become positive or negative. Okay. So H plus 1, because it's sitting with somebody negative, so that's why giving this guy a plus charge. So H plus 1 and PO4 minus 3, H will get again 3 and PO4 will get 1. So that's your answer. And again, H will get the 3, 3 comes down, and this one goes down, H3, PO3. So these are the names for 3 different acids. Hydrophosphoric acid is H3P, phosphoric acid is H3PO4, and phosphorus acid is H3PO3. So guys, I hope this makes sense. Make sure you watch this video a couple of times, then do exercise C, and test yourself if you understand this, okay? We'll see you guys in the next video.